Hi everyone. In this lecture, we're going to pick up from where we left off last time and clean our HR analytics data, but using Python and Pandas. Let's not waste any time and get started. Okay, and here I am now back inside of Jupyter Notebook. In the last lecture, we just imported our dataset, as well as having a quick overview of it, just to make sure that it had all imported okay. The first data cleaning task on our list here is to check for any duplicates. So let's get started with this one now. As hopefully you'll be able to remember from our theory lectures on Pandas, to check for duplicates, we can use the .duplicated method. So I'll just go ahead here and say df.duplicated, and then this will return a Boolean Pandas series for all of our rows, telling us if we have any duplicated data or not. Currently, we're only able to see our first and last 5 rows, so to get a summary of our dataset, we could pass in either .any or .sum to the end of this, and that'll tell us whether or not we've got any duplicate data at all. Another little trick that I'll also show you is that we can actually index our data frame using the duplicated method. So if I just say here df and then open a set of square brackets, we could actually pass df.duplicated into our square brackets, and then when we run this, it'll return a data frame with all of our columns and any duplicate rows, which is a very helpful way to see what data is actually duplicated. If we did have any duplicates, then we could just use the df.dropDuplicates method and then set in place to be true, and this would then modify our original data frame by removing any duplicate data. For our next task, we have to check for any missing data. And as we looked at in our lecture on how to deal with missing data in Pandas, we can use the .isNA method to do this. This will just return a Boolean data frame of true and false values for if that cell is missing or not. The best way of using this method is actually in conjunction with the .any method though, as instead of returning every cell, it'll return a summary of the entire column, as we can see here. In this case, we don't have any missing data, but if we did, we could either drop the rows with dropna or fill the missing points with fillna, which were the 2 methods that we've looked at for dealing with missing data. Checking for typos or spelling mistakes in Python is actually a little harder than it is in Excel, as due to its nature, it's not as visual as Excel, as well as the fact that there's also not any built-in spell checking functionality. The best way of actually checking for this in Python is to use the unique method, which will return each unique value in a specified column. We would usually only check for typos in our categorical columns. So for example, I'll just go through here and check for unique values in our department column, which we can see are sales, research and development, and then also human resources. But if, for instance, one of these values had a typo in the form of an extra space or incorrect letter or spelling mistake, then this would show up as another unique value. So we could very quickly and easily see that there is a typo that we need to deal with. For larger datasets, such as this one, going through and checking all these columns manually could take quite a while, so we could actually use a for loop to automate this process for us. We'll first need to select all of our categorical columns, which we'll do with select_dtypes. I'll create a new variable called categorical columns, and we'll say that this is equal to df.select underscore dtypes, and then for the vast majority of situations, the object data type should select all of the categorical columns, as most of these will have the object dtype. So for our argument, I'll just say that this will include object. If we ran this as it is though, this would select all of the columns and associated data, which we actually don't want or need. So what I'll do is pass in .columns at the end. Now we've got a variable which contains all of the column headings for our categorical columns. And then we can take this and loop through these columns with the use of a for loop. So for col in categorical columns, and then we'll need to create a variable containing all of the unique values, which will be equal to our data frame. But then instead of specifying a fixed column, we actually want this to go through each column in our data frame. So I'll put in our temporary col variable in here, which we set in our loop, which will just iterate through each value in our categorical columns variable. We just want this to print out the unique values. Okay, perfect. So now we get a list of all of the unique values in each column. And quickly looking through here, we can see that all of these values look fine. But before moving on though, I will just quickly show you a way that we can go through and improve our for loop, just to make its output a little nicer and easier to read. I'll leave you to work out how the code works, so I won't explain it too much, but essentially what we're going to do is nest another for loop inside of our main loop here. I'll modify our first print function to just show the column, and then below this, let's create a new for loop to iterate through and print all of the unique values. So for value in unique values, which is the variable that we made here, and then I'll set up an f string, which will just be a dash, a space, and then our value like so. And if we run this now, instead of our output from before, which was a little messy, we get a nicely formatted and easy to read list. So this here is some helpful and reusable code that you can use for any dataset that you might be working on. Okay, next up, we're going to drop all of the unnecessary columns from our data frame. In our Excel section, we dropped the business travel, daily rate, employee count, hourly rate, job involvement, non-companies worked, over 18, overtime, relationship satisfaction, stock option, total working years, years in current role, years since last promotion, and finally, the years with current manager columns, as we can see up here from the list at the top. There's a couple of ways that we could go about removing these columns. So either with the drop method, del or delete keyword, or alternatively by indexing our data frame to select a subset of the columns, which would just remove any columns that weren't selected. But for this example, I'll use the drop method. We'd just need to say df.drop and then pass in a list of the columns that we want to drop, starting with the business travel, daily rate, and so on for the rest of these columns. I'll just fast forward while I go through and add the rest of these in. Okay, so we've now specified which columns we want to drop. So we'll now just need to go through and set the axis to be equal to 1, as by default, Pandas operates with an axis of 0, which is actually for our rows. And finally, I'll set the inPlace argument to be equal to true, so that this code modifies our original data frame rather than returning a new data frame. Okay, so we're getting close to finishing now. All that we've got left to do is rename our monthly income and monthly rate columns, add in our new columns for the ages and ROI, and finally replace the values in our categorical columns. We've not yet covered how to rename columns in Pandas, but it's actually super easy. We'll just need to use the rename method. For our arguments, we'll start by providing a dictionary with the key set to the name of the column as it is currently, and the value set to be whatever we want this column to be called. Currently, our column is called monthly income, so that'll be our key, and we want it to be called employee salary, so that'll be the value. And then I'll go through and do this for our second column, which is the monthly rate, which we want to be called employee revenue. And like we did when dropping columns, we'll need to set our axis to be 1 so that it operates across our columns, because these labels don't exist for our rows. And then we'll also just make this be an in-place change too. Okay, nice one. So this is going really well so far. We'll now move on to adding some new columns to our data frame. And these will be for if the age is less than or equal to 25, if the age is greater than or equal to 55, and finally, an ROI column. And to create these columns, we'll just follow the exact same process that we looked at in our lecture on data frames. We'll start with the name of our data frame, and then square bracket notation. But if we enter in the name of a column that doesn't exist in here, then instead of indexing it, we can actually create a new column. So df, and we'll say that this is equal to our age column, where the value is less than or equal to 25. And this will then create a Boolean column based on this condition. So a super simple process. If we check the value counts on this, we'll see that the only two values in this column are false and true, and then with the relevant number of values for each category next to it. Well, let's go through and repeat this same process, but this time for where the age is greater than or equal to 55. Our last column was for the ROI, and this will just be calculated with the same formula that we used before. So the employee revenue column minus the employee salary, and the result of this then divided by the employee salary. To get this as a percentage, we'll then multiply this value by 100. If we check the contents of our data frame, we'll find that at the end, we've got our 3 new columns that we just created. The final data cleaning task that we needed to do was go through and replace all the numbers in our categorical columns, which were the education, environment satisfaction, job level, job satisfaction, and standard hours columns, with descriptive labels instead. To do this, we'll first create a couple of mappings that will associate each numerical value with its corresponding label, and then we'll apply these mappings to the respective columns in our data frame. Our mappings will just be dictionaries with a key value pair, so we'll have one mapping for each column. I'll start by creating the mapping for our education column, which I'll call education map, and then this will be a dictionary with a key value pair for each of the 5 numbers in our education column. We'll use the exact same labels as we did in Excel, with 1 being high school, 2 being undergraduate, 3 being postgraduate, 4 as professional certification, and then 5 will be other. Let's now go through and do the same for our environment satisfaction map, which will be dissatisfied, neutral, satisfied, and very satisfied. I'll now fast forward and add in the remaining mappings for our job level, job satisfaction, and standard hours. Okay, perfect. So we've created our 5 mapping dictionaries, which are all using the same values as what we had in Excel. We'll now need to go through and actually apply or map these to our data frame columns. And to do this, we could use the map method, which is available in Pandas. And this works in a very similar way to the map function did that we looked at towards the end of our section on Python. And let's start here by applying the mapping to our education column. We'll start by indexing this column, and then we'll call the map method on this and pass in the education map dictionary that we just created. Let's run this, and there we can see that our numbers have been replaced with the different categories that we just set. And now we know that this works, I'll go back and assign the result of this back to our education column. And I'll now go through and repeat this process for the rest of our columns. Okay, so great job there everyone. We've now gone through and completed all of the data cleaning steps that we needed to do for this section. Let's quickly just check the head of our cleaned data frame, just to make sure that all of our columns are present and that our data all looks okay. And everything looks to be fine here. We've got all of our columns, and then all of our data matches what we'd expect. The final thing that we'll need to do is export our clean data frame to a CSV file, so that in the next section, all we need to do is load this cleaned dataset in, and then we can work directly on our cleaned data, as opposed to having to recreate these cleaning steps. This can be done very easily with the to_CSV method. For our arguments, we'll start by passing in what we want to call this new CSV file. And then also, as an optional argument, I usually set the index to be false, as otherwise it'll just create an extra column containing our row labels, which in this case we can see are just numbers that we don't need. If we run this cell, it'll create a CSV file which will be located wherever your Jupyter Notebook file is. So if I check the section folder where I have my notebook file, then we'll see that there's a CSV file here called cleaned HR data, which is what I set here in our export method. And this CSV file just contains the contents of this data frame. So basically all of the data that we just cleaned. Great job everyone. I hope that this section has helped you to see and understand some of the ways in which we can apply Python and Pandas to clean some real-world data. In the next section, we'll move on to analysing and visualising this cleaned data. Thanks everyone, and I'll see you all there.